In this lecture, we're going to learn about legacy enumerated types, or old enums as I like to call them. Let's look at a simple example. Here we have an older way to declare an enumeration in our C++ code. But this is really old and not recommended anymore. Enum classes were introduced in C++ 11, and they introduced a safer way to work with enums. You can declare your enums like this if you want, but this is going to give you a few problems. The bigger one being that legacy enums implicitly transform to int. So you may think that this is good because you can print them on stdcout and be on your merry way, but this introduces the problem because you can compare enums of different types. So for example, here we have two enums. One is direction and the other is tool. For direction, the possible values are top left, top right, center, bottom left, and bottom right. For our tools, for example, we can have pen, marker, and all kinds of crazy tools we might need in our painting applications. If we go down, you see that we have two variables declared. One is of direction type. It is initialized with bottom left. The other is the tool, which is initialized with pen here. But the problem is we can do something like this, and it is going to be really confusing. What do we mean by tool greater than direction? This is really confusing, and legacy enumerated types allow you to do this. And for this reason, it is really recommended to use enum classes like we have seen in the last two lectures. I am showing you this for completeness, but I strongly don't recommend you to use this in modern C++ code because older enums have no place in modern C++. Legacy enumerated types support all the cool features we have seen for enum classes. For example, you can customize the underlying integral type. For example, use car like we have seen. You can change the values to represent each of these enumerators. You can do all kinds of crazy things. But we're not going to see that because it really is the same like we have seen for enum classes. For now, we're going to head over to Visual Studio Code and show you some possible problems you might face if you use legacy enumerated types like we have here. Okay, here we are in our working folder. The current project is old enums. We're going to grab our template files and we're going to put them in place. And let's open this in Visual Studio Code. We can actually grab this folder and drag that and drop that into Visual Studio Code. This is going to open this. And we can open main CPP and clear the file and close the pane here. We don't need it anymore. And we are going to head over in front of the main function and put in our two enumerated types using the older syntax. Let's align this properly. We have two guys here, and please note that we can even use enum classes. If we do that, you're going to see that this is going to work. This is going to be valid C++ syntax. This is going to work, but I want you to see the possible problems that might come up if you try to use legacy enumerated types. Okay, let's go down and try to use them. We are going to go in the main function here and declare two variables. One is going to be direction, the other is going to be tool. Once we have these guys declared, we can print them out, and you're going to think that this is really cool. So we're going to say stdcout, for example, and we're going to say direction, and we're going to say stdcout tool, and we're going to say tool. This is going to print out. If we do this, you're going to see that Visual Studio Code is going to accept this. It's not going to give us squiggly lines. Okay, now that we have this, we can try and build this. Let's do that using GCC. If we go up here, you see that the build is good. We can bring up a terminal and try to run this program here. Let's clear properly. And we're going to run Rooster. You see that it's going to say direction is 3. Because our direction is initialized to be bottom left, and bottom left is at the fourth location in our guy here. So top left is going to be 0, top right is going to be 1, center is going to be 2, and this guy is going to be 3, bottom left. If we put in top left, for example, and build again, let's use GCC to try this out. The build is going to be good. We can clear and run rooster. We should get a 0 for a direction. And the tool is pen, which is the first in our enumerator here. So it is going to be 0. This is working like we want. And you might think legacy enums are cool because they allow me to implicitly convert to an integer and print them out. But the problem is this can be really confusing because you may try to compare two different types. And the compiler is going to accept that and give you some junk value. What do I mean? Let's do stdc out here. And we're going to say tool greater than direction. Why not? We're going to do something like this. And we're going to put in our parentheses and say tool greater than direction. Now, try to think about this statement here. What does it really mean for a direction to be greater than a tool? This doesn't make sense. And the compiler is going to allow us to do this. And this is really bad. This is why you shouldn't really use legacy enums like we do here, because they're going to make your code confusing. Let's try and build this. You're going to see that this is actually going to compile fine. Build finished with warnings. At least the GCC is going to give us a warning. And it is going to tell us comparison between enum tool and enum direction. But this is just going to be a warning. The program is going to compile fine. If we try to run rooster and say rooster, you're going to see that tool greater than direction is false. But what does it really mean? This is junk value. It doesn't really mean anything. This is confusing. You shouldn't do this. If we change this code to use enum classes, we're going to change a few things. One is we want to be able to initialize our things like this because we will need to specify the type to which this enumerator belongs. The second thing is that we want to be able to print an enum type like this directly, and the compiler is going to give us a compiler error if we try to do this. Our code is not going to compile. Let's try and introduce those changes, and it's really easy. All we have to do is say enum class here, and we're going to have to specify the direction here. Colon. This is the syntax we should use like we have seen for enum classes. Here we should say tool colon pen. And once we do this, we're going to get squiggly lines if we try to print this out. Let's comment out the line to compare these guys. So we're going to get a compiler error because enum classes don't implicitly convert to integers. Let's try and build with GCC. You're going to see that we get a compiler error, but all the error is saying here is that we can't implicitly convert from an enum to an integer and print that out. stdc out is not going to know how to print this direction here. And this is really good because we don't want our enum here to implicitly convert to an integer. If we want that, we have to do that ourselves. But we don't want our compiler to insert all these implicit conversions without our knowledge as developers. So this is really good. You may think this is bad, but I think it is good. Another thing is that now, if we try to compare things like this, we're not going to just get a warning. We're going to get a hard compiler error. And the compiler is going to stop us from doing this because we have no business really comparing directions and tools like we are doing here. This doesn't really make sense. If we're trying to build this, we're going to get a compiler error, and hopefully the compiler error is going to be meaningful, no match for operator, greater for this guy. And this is the error we're going to get. And hopefully you understand that legacy enumerated types are bad because they really make your code unintuitive. The compiler might insert all these implicit conversions. But please note that some people like to use legacy enumerated types. I personally think they are unsafe to use, but now that you know all these things, it is going to be your choice as to which technique you choose to use. One other thing you should know is that we have the same facilities we had for enum classes for legacy enumerated types. For example, if we take out this class here, and let's take this out and uncomment this again. I don't think we need to do this comparison. So let's take this out and show you what I want you to see. Let's try and build this. We're going to build with GCC. The build should be good, clear. And we can go on top of, for example, and change the value we are using to represent top left to 10. Why not? We're going to do equal 10. And you can see that this is the same syntax we used for enum classes. If we build and run this, the build is going to be good. We can clear and run rooster. You're going to see direction is 10 because we changed this guy to start at 10. We can even change this to -1. Why not? It's going to work because this is still represented by an integer under the hood, or I should say specifically int. If we build this, it is going to build. The build is good. We can even change the underlying type to represent our enumerated types here. For example, we can change this to car, and you're going to see that this is going to compile. Let's use GCC to build this, and you're going to see that it is going to work. We can clear and run rooster, and you see that direction now is, what is it? It is not printed. Why is that? -1 can't be a character. Let's change this to, for example, 64 and see what we get. We can clear and run with GCC. We're going to build with GCC and run rooster. This is being interpreted as a character by stdcout. And I didn't really think about this. This is a new learning chance even for me. I like this. But we can even change this to unsigned car if we want. Let's see what we get. Unsigned car, like we did. And if we try and build this, let's see what we get. The build is good. As expected, we can clear and run rooster, and we see the same thing. This is giving us characters, but if you want, you can explicitly cast this to an unsigned int, and it is going to print as a number. Let's do that. We can say static cast, and we want to cast to unsigned int, and what we cast is direction here. I think we can do this. Let's wait and see Visual Studio Code take out these squiggly lines. And if we build now, the build is going to be good. We can clear and run rooster, and we see that we have a 64 here. So this is really all we set out to do in this lecture. The message is legacy enumerated types can be unsafe, but it is going to be your choice if you want to use them or not. They are available to you. If you want, you can even use enum classes. You're going to choose whatever makes sense for your application. We are going to stop here in this lecture. In the next one, we're going to learn about type aliases. Go ahead and finish up here and meet me there.